this lesson, we will be looking at dividing radical expressions. Here's our first example. We have the square root of a fraction, 18/4. First thing you want to look at is, can I simplify what's under the radical sign first? That can always help to simplify it first. And both of these numbers are actually divisible by 2. So when I simplify it, we would have the square root of 9 halves, 9/2. Now let's look and see. When we break both of these down, when you have a fraction under a radical sign, it is the same thing as having the square root of 9 on top and the square root of 2 on the bottom. Well, we know that 9 is a perfect square, so we can take the square root of 9, which is 3. So now we have 3 divided by the square root of 2. Now, when you're doing rational expressions like this, you can never have a radical in the denominator in your final answer. So we have to do something that we call rationalize the denominator. In other words, get rid of the radical. We want a rational number, not an irrational number on the bottom. So what we can do is we can multiply what we have times something that's equal to 1. And anytime you have a number times or divided by itself, that equals to 1. So what we're going to do is we're going to take the denominator, which is the square root of 2, and we're going to make a fraction. Square root of 2 divided the square root of 2. Now, any number divided by itself is 1, so all we are doing is we're multiplying our fraction by something equivalent to 1, so it doesn't change it. Now, what we can do is we multiply across. 3 times the square root of 2 is 3 times the square root of 2. On the bottom, we have the square root of 2 times the square root of 2. We can multiply what's under the radical sign, so that would be the square root of 4. And we can take the square root of 4, which is 2. So our denominator is 2. So here's our final answer. This is just going to take some practice getting used to. So let's look at another example here. Here we have the square root of 7 halves. First, I look to see if there's any way I can simplify the fraction underneath the radical sign, and 7 halves is simplified. So now, having 7 halves, we can break it down. It's the same thing as having the square root of 7 on the top in the numerator and the square root of 2 in the denominator. We have learned that in our final answer, we have to have no radicals, no square root signs in the denominator. So to rationalize it, to make it a rational number, we're going to take what's under here, we're going to make a fraction equal to 1, so we're going to take the square root of 2 divided by the square root of 2. And now what happens is we multiply across. So on top we have the square root of 7 times the square root of 2. You can multiply everything that's underneath together. That's the square root of 14. And on the denominator we can multiply the square root of 2 times the square root of 2, and that would be the square root of 4. We know that we can take the square root of 4, which is 2. So now we have the square root of 14 divided by 2. Before we finish, we have to ask ourselves, is there any way I can simplify the square root of 14? If I think about my factor pairs for 14, are there any perfect squares? There are not. So that is our simplified answer, the square root of 14 divided by 2. Here we have the square root of 13 divided by the square root of 5. We're going to rationalize the denominator again. That means that we're going to take the denominator and we're going to make that into a fraction equal to 1 by putting the same thing on the top and the bottom. We multiply across. So on top we have the square root of 13 times 5. And 13 times 5 is 65, so now we have the square root of 65. In the denominator, we have the square root of 5 times 5, which is 25. And the square root of 25 is a perfect square. That's going to be 5. So now on top, we still have the square root of 65, and we have 5 in the denominator. So we've rationalized. We've made the denominator a rational number. Now, is there any way we can simplify 65? So think of factor pairs that equal 65. We have 5 and 13. None of these are perfect squares, so this is as simplified as we can do. The square root of 65 divided by 5. It's called rationalizing the denominator, which means that we're making the denominator a rational number instead of an irrational number. No radical signs in the final answers in the denominator. Okay, here we have the square root of 7 divided by the square root of 8n. Again, we have this radical sign located down here in the denominator. So to get rid of it, we're going to create a fraction where we use that as the numerator and the denominator. So now on top, what we have is 7 times 8n, which is 56n. And on the bottom, we have 8 times 8, which is 64, and we have n times n, which is n squared. And you begin to see a pattern that when you have the same square root times the same square root, to take the square root of it, you take the square root sign away. The square root of 64 is 8. The square root of n squared is n. Notice it's the same thing without the radical sign. So it basically eliminates the radical sign in the denominator. Now we have the square root of 56n on the top and 8n on the bottom. Now we can't cancel out the n's because one is under a radical sign and one is not. So the only thing left that we can do is look to see if we can simplify 56. So when we think of factor pairs for 56, we have 1 and 56. We have 2 and 28. None of these are perfect squares yet. We have 4 and, 14. Here I have a perfect square. So I could break 56 down into 4 times 14, and I'm going to keep the n under there. I can take the square root of 4, which is 2. So on the top I have 2 square root of 14n, and on the bottom I have 8n. Now here I could actually simplify it a little bit more, because on the outside of the radical sign I have a 2 and I have an 8. Both of those are divisible by 2. That would become 1. This becomes 4. So our final answer is the square root of 14n divided by 4n. Lots of steps in that one. Again, this is just baby steps from learning the things. We've already learned how to simplify. We've already learned how to multiply. So we're using all of those steps in doing this. Okay, we have the square root of 13 divided by the square root of 2. Neither one of them are perfect squares. We can't simplify them any. So we're going to rationalize the denominator by taking the denominator, making a fraction. So we take it and copy and paste it into the numerator and denominator. On the top, we have the square root of 13 times 2 underneath the radical sign. That's the square root of 26. On the bottom, we have the square root of 2 times 2, which is 4. And we know that the square root of 4 is 2, so we just have 2. Again, it just eliminates the radical sign. Now we have 26. Factor pairs for 26 are 1 and 26, and 2 and 13. None of these are perfect squares, so this is as simplified as we can get. 26 divided, or the square root of 26 divided by 2. Another example, we have the square root of 28 divided by the square root of 3s. We can't simplify this any, so we're going to rationalize the denominator. We want to make the denominator a rational number. So we have the square root of 3s divided by the square root of 3s that we're going to multiply this by. Again, we're just multiplying this original one times something that's equivalent to 1, so it doesn't change it any. On the top, we have the square root of 28 times 3s. That would be the square root of 84s. On the bottom, we have the square root of 3s times 3s, and that would just be the square root of 9s squared, which of course, when you take the square root of it, is just going to be that without the radical sign, so we just have 3s on the bottom. Now 84, can we simplify 84 any? Let's think of factor pairs for 84. We have 1 and 84. We have 2 and 42. We have 3 and 28. We have 4 and 21. And right there, we'll notice that the 4 is a perfect square, so we could break it into this. So this is the simplifying part. Instead of 84, we're going to break it into the square root of 4 times the square root of 21. And then we have our s. We can take the square root of 4, which is 2. So on the top, we have 2 times the square root of 21s. And on the bottom, we have 3s. And that's our final answer. I'm going to now look at a couple examples off of the assignment that you're going to be doing. Change my thing here. Pull this up. Let's look at a couple of these just for the fun of it, because we love doing this. I don't know which one randomly to pick, so let's randomly pick number 15. Okay, on number 15 we have negative right here, minus a negative 9 divided by 2 times the square root of 45. So we have to think about how to do this. We're going to rationalize the denominator. So we're going to create a fraction, 2 times the square root of 45 divided by 2 times the square root of 45. We just copy and paste what this denominator was. Now, let's multiply on top. On the top, you have a 9 times a 2, which is 18. It's negative. Negative 18. We multiply what's outside the radical sign together, and we keep this underneath the radical sign. On the bottom, if you just remove, we have to do the multiplication. So we have on the outside, we have 2 times 2, which is 4. And underneath, you have the square root of 45 times 45. So that is just going to be 45. If you take the square root of 45 times 45, it's 45. So on the bottom, what we have is 4 times 45. We multiplied what was outside, and then we multiplied what was underneath and took the square root. Now 45 times 4 is 180. So what we have now is negative 18 times the square root of 45 divided by 180. Everything outside of the radical sign can be simplified. So I can divide 18 and 180 both by 18. That takes this one away, and this one becomes 10. So now we have the square root of 45 divided by 10. But 45 can also, we have factor pairs that we can use to break it down. For 45, we have 9 times 5. So if we take the square root of 9 and the square root of 5, the square root of 9 is 3. So now we have minus 3 times the square root of 5 divided by 10. And there is our final answer. That one had a lot of steps. You may need a separate sheet of paper to work these on. Let's just take another one. Let's randomly pick number 18. On 18, right down here, we have the square root of 10 on the bottom. So we're going to rationalize it by multiplying both the top and the bottom by the square root of 10. Remember, this just cancels out the radical sign on the bottom, so we have 10 on the bottom in the denominator. On the top, on the outside, we have 5. Underneath the radical sign, we have 3 times 10, which is 30. Now, is there anything we can simplify? 30 does not have any factor pairs that are perfect squares, but on the outside, we have a 5 and a 10. Both are divisible by 5, so that would leave us with a square root of 30 divided by 2. Maybe we should try one more. Which one should we try? Let's look at number 8. Before we start anything, we can simplify what's underneath. Just look at the fraction itself and say, can I simplify that fraction any? Well, both 22 and 200 are divisible by 2. So that would leave us with the square root of 11 and 100. That makes it a little bit better. We have a to the 5th power divided by a to the 1st power. And remember, when dividing with exponents, we actually subtract. So this one cancels out one of these, and you just have a to the 4th on top. So there, I just simplified the fraction to begin with. It was under the radical sign. Now I look at it and I say, okay, On the top, I have the square root of 11a to the fourth power, and on the bottom, I have the square root of 100, which happens to be a perfect square, so that works out great. Now on the top, I have the square root of 11 and the square root of a to the fourth. We've learned that when you have a variable with an even exponent, you can take the square root of a to the fourth power. It's just going to be half of it, which is a squared. So underneath, I have 11. And when I take the square root of a to the fourth power, that becomes a to the second power on the outside. And then the square root of 100 is 10. So here's our final answer. So you just have to kind of work through these step by step, see what you can do, and good luck.